Lesson 10.5, Graphing Square Root Functions. Your objective is to graph square root functions and to translate the graphs of square root functions. Vocabulary. A square root function is a function that contains the independent variable in the radicand. An example is y equals radical 2x. A square root function is a function containing a square root with the independent variable in the radicand. The parent square root function is y equals radical x. The table and graph below show the parent square root function. You can graph a square root function by plotting points or using a translation of the parent square root function. Finding the domain of a square root function. For real numbers, the value of the radicand cannot be negative. So the domain of a square root function is limited to values of x for which the radicand is greater than or equal to 0. What is the domain of the function y equals 2 radical of the quantity 3x minus 9? So you have to think, the stuff inside the radicand, 3x minus 9, has to be greater than or equal to 0. It cannot be negative. So then we're going to solve for x. We'll add 9 to both sides and divide by 3. And we get x is greater than or equal to 3. So the domain of the function is a set of real numbers greater than or equal to 3 for this function. Graphing a square root function. Graph the function L equals 1/5 radical P, which gives the current L in amperes for a certain circuit with P watts of power. When will the current exceed 2 amperes? So first you need to make a table. We have power, which is our independent variable, and our current, which will be our dependent variable. We're going to plot the points on a graph. Let's see, so at 0 we have 0. Oops, let me make that a little bit bigger. At 10 we have 0.6. And at 50 we have 1.4, and at 100 we have 2. Once you draw your graph, plot your points, you should connect the dots to draw your graph. And notice the shape of this is very similar to the parent function. It's just slightly different. So according to this, the current will exceed 2 amperes when the power is more than 100 watts. Vertical and horizontal translations. Vertical translation is when the graph moves up and down compared to the parent function. So for any positive number k, graphing y equals radical x plus k translates the graph of y equals radical x up k units. For any positive number k, graphing y equals radical x minus k translates the graph of y equals radical x down k units. For a horizontal translation, for any positive number h, graphing y equals x plus h, notice that that's under the radicand, translates the graph of y equals radical x to the left h units. And for any number, positive number h, graphing y equals x minus h translates the graph of y equals radical x to the right h units. Explain what the graph of y equals radical x plus 2 looks like. For this graph, the graph of y equals radical x, the parent function, is shifted 2 units up. Explain what the graph of y equals radical of the quantity x plus 3 looks like. So notice again, plus 3 is inside the radicand. So for the graph of y equals radical, the quantity x plus 3, the parent graph is shifted 3 units to the left.